Hello everyone, I'm Zijie Wang. We're glad to be here to present our SuperNOVA. So recently, we have seen computational notebooks such as Jupyter Notebook and Jupyter Lab have become the most popular development environment for AI practitioners. So what are computational notebooks? So those notebooks are documents including different cells, such as a code cell or text cell, and the user can run different code cells and can see the output right after the code cell. The output can be some interactive visualizations. And in fact, we have seen often researchers and developers have developed many interactive visualization tools tailored for computational notebooks. So developer can directly call the interactive visualization directly in their computational notebooks. However, even though we have so many notebooks, we still do not know what's the best way to design our visualizations for the notebook environments. And to address that challenge, we conduct a comprehensive schematic review of those notebook tools. First, to collect some notebook samples, we scraped 8.6 million public notebooks from GitHub, and we collect 64 academic papers. In total, we collected 163 notebook interactive visualization tools. Then we conduct a systematic review of those tools. So we present an organizational framework to organize those notebooks and characterize them based on the target users, data communication, modularity, sense-making context, and data source. To begin, we're going to talk about the targeted users. Most of the tools targeted at scientists, but also many tools targeted scientists like biologists and physicists. We're also increasing the number of tools that target educators and students. So I've seen professors and other teachers make assignments by using those interactive visualizations. So the one takeaway is we should design the visualization tools based on targeted users' workflows. Then we look at notebook visualization data communication. So he will look at different ways the user can pass data from notebook environments to the visualizations. So some tools do not use communication. They load data from external servers, external sources. Many tools use one-way communication, so you can pass data from the notebook to the visualization. Also, some few tools also have a two-way or bidirectional communication. So you not only can pass data from the notebook to the visualization, you can also pass data from visualization to your notebook. Also notice multi-data communication channel means you can support fewer notebook platforms, so there is a balance and trade-off there. Regarding the data source, many tools use runtime data in a notebook to create the visualization. So a creative way also use the code and text in a notebook to create visualizations, and some people also use external data. So we should take advantage of access to unique data in the notebooks to create visualizations. Regarding the sense-making content, we see two different display styles, so on-demand and always-on. For the on-demand, we see the visualization right below the code cell, so they will scroll with users' notebook. However, with always-on visualization display, they will be displayed maybe on the side or on the bottom of the notebook, you can always see them. So designer can think about situational sense-making versus continuous monitoring when choosing their display styles. Also notice there's different modularity of different tools. Some tools are monolithic, so we have everything is in one code cell. The user can use different tabs and navigate into the tool internally. Many tools will have modular layout, so you can use call different functions to summon different visualizations. And here, designers should think about if they want exploratory or exploitative data analysis to when they're designing the modularity of their tool. Finally, we also conduct impact analysis where we use our framework to predict the count of GitHub stars and the count of paper citations. And we notice that tools supporting one notebook platform have a greater impact. To see more detail, please read our papers. And finally, we develop SuperNOVA, an interactive browser that supports all the visualization tools, so users can easily browse different notebooks tools to gain design insights and implementation details. That's the end of my talk. You can learn more about SuperNOVA by reading our paper. You can also try out SuperNOVA directly in your browser by visiting the link on the top right. Thank you.